Okay, in this section 4-8, the topic is isosceles triangles, and in this particular section we're going to be focusing only on isosceles triangles. Now, first thing we want to do is take a look at identifying the parts. Remember, in an isosceles triangle, two sides are congruent, and so if these are the two sides that are the same, those two sides will be called the legs of the isosceles triangle. The remaining third side is called your base, and then so that helps you identify all of the sides of the triangle. Let's talk about the angles of an isosceles triangle. The two angles that are connected to the base, okay, those are called your base angles, and we have them labeled here as such. And then the third angle is called the vertex angle. Alright, so in an isosceles triangle you have two legs that are the same and a base. Okay, and you have two base angles that are connected to the base, and then the angle across from the base is the vertex angle. Now, it's important that you're able to identify these parts of an isosceles triangle, because you could have a problem that says the vertex angle of an isosceles triangle is 58 degrees, and you have to know where that angle should be labeled. Or it could say the base of a triangle has a length of 12 inches, and you need to know which side would be the base, and so on. So it's important to make sure that you can identify those 6 parts. Alright, next thing we come to is a theorem, and it's a theorem that says if the sides are the same, then the angles across from those sides are the same. Okay, so for example, let's say I have an isosceles triangle and the legs are 5. So this side is 5 and this side is 5. Well, the theorem says if the sides are the same, then the angles across from those sides are the same. Okay, so what that means is if these are my two sides that are the same, 5 and 5, okay, then the angles across opposite from those two sides would be the same, which means that this angle would be the same and this angle would be the same. Now at this point we don't know what the degree measure is, but we do know that they have to be congruent. Alright, and so basically what we learn from this is in an isosceles triangle the base angles are always congruent. Okay, and likewise it works backwards as well. If you know that the base angles here are the same, then you know that the sides across from those base angles would have to be the same. Alright, so if you've got a triangle where two angles are the same, then you know by this theorem that it forces the two sides across from them to be the same, and then you have yourself an isosceles triangle. Okay? Alright, so what kind of problems are we going to be faced with now from this? Okay, we're going to be faced with problems like this where we have some of the sides or the angles labeled in terms of x, and it's going to ask us to either find x or find the angle or find the side. Alright, so in a problem like this, I have two angles that are labeled here, one as 2x minus 4 and one as 68. Now, take a look. We've got two congruent markings here. Alright, so that signifies that we do have an isosceles triangle, and remember, the angles across from those sides are going to be congruent. So if these two sides are the same, then the angles across from these two sides are the same. And that allows me to set up an equation. Since these two angles are the same, I can write this. 2x minus 4 equals 68. Okay, because these are the two base angles that they've given me. And remember, the base angles have to be congruent. Now it's just a matter of solving the equation that we've written down. We can add 4 to both sides. 2x equals to 68 plus 4. 2x is equal to 72. And I can divide that by 2 and get x is equal to 36. Alright, so remember the key is being able to set up an equation based on the parts that they give you. Anytime you've got a problem that asks you to find x, okay, you need to set up an equation that you can use to find x. Alright, take a look at the next one. In this next one, I have this angle labeled with 1 mark and this angle labeled with 1 mark. Okay, remember, these congruent markings for triangles show that these two angles are the same. And remember, again, the theorem that we looked at, if two angles are the same, then the sides across from those two angles are the same. And then so now that allows me to set up another equation. I can write 3x minus 6 equals 2x plus 6. Then from here we've got an equation we need to solve for x. On x's on the all the x's onto one side, regular numbers on the other. Anything that goes across is going to change sign, so I'll have 3x. 2x changes to minus 2x. The 6 is staying put, it's not moving, but the minus 6 on this side is going to come across, change to plus 6. 3x minus 2x is x. 6 plus 6 is 12. And then so x equals 12 in this particular one. Okay, several more we want to take a look at here. Directions are still the same, find x. Alright, so on this one we have 1 mark here for this side, 1 mark here for this side, so that means that those two are the same length. Okay, now, when we're looking at this one, we can't just say that these two are equal to each other, because remember, it's the angles across from the sides that are congruent, that are equal. So what that means is that the 5x is across from this side, okay, but the angle that's across from the other marked side is blank. It's not the 70 degrees, okay? So we can't say 5x equals to 70 degrees. The 5x doesn't equal the 70 degrees. The 5x equals the blank angle, all right? So keep that in mind. Make sure that when you're trying to figure out which angles are congruent, it's the ones that are across from the sides that are congruent, all right? Not the included angle, so be careful with that, all right? So the question is, what do? I can't make an equation that says 5x equals blank, right? We can't do that. However, we do have enough information to fill in this blank angle with an expression, and here's what I mean by that, okay? If these two angles are the same, and this one is labeled as a 5x, well, what do you think the other one should also be labeled as? 5x. They're the same. Okay? Now, you might be saying, Coach, well, how does that help me? Because 5x equals 5x is not an equation that helps me any either. That's true, but that's not the equation we want to set up. Remember what we talked about earlier in the year, in the first 6 weeks? Okay? All the angles on the inside of a triangle add up to 180 degrees. All the angles on the inside of a triangle add up to 180 degrees. And so when you're looking at this, the equation that I want to set up here is 5x plus 5x plus 70 equals to 180. All right? So again, we'll label this blank angle as 5x because it's equal to this one. Then I have all three angles, and we know all three angles on the inside of a triangle add up to 180 degrees. Now I've got an equation that I can solve for x. All right, so 5x plus 5x is 10x plus 70 equals to 180. We can move 70 over. 10x is equal to 180 minus 70. 10x is equal to 110. Let's divide that by 10. And then we will have x is equal to 11, and then that's your answer. Okay? If you're unsure that you've done it correctly, take 11, plug it into the x's for all of the angles. 11 times 5, 55. Here, same thing, 55. 55 plus 55 is 110, plus 70 makes 180. And if they all add up to 180, then you know you've done it correctly. All right, what about this one? Again, I've got two sides that are congruent here. And so remember, the angles across from those sides would also be congruent. So if this one is 2x, then the one over here I can label as 2x, kind of like what we did in the last one. The blank one is also 2x. And now take a look. I've got all three of the angles inside of the triangle. I know that they add up to 180 degrees. 2x plus 2x equals to, nope, not equals to, because we've got a 90 degree, we've got to add to that, equals to 180 degrees. All right? So again, all three angles on the inside of a triangle add up to 180 degrees. And so now I've got 2x plus 2x equals 4x plus 90 equals to 180. I can subtract that now from both sides and get 4x is equal to 180 minus 90. 4x is equal to 90. Ready now to divide by 4, and when I do, I get x is equal to 22.5. Once again, if you're unsure, you can plug that back in and check your answer to see if all the angles add up to 180. Okay, now the next problem is a little bit different. Okay, so this time I've got two triangles. They're connected at a vertex here, and I have this angle labeled as 2x, and I have this angle labeled as 4x plus 5. Now, in the left-hand triangle, I have one mark here and one mark here, so it is isosceles. Two sides are the same. In the right-hand triangle, I've got 2 marks here and 2 marks here. So again, it is also isosceles. So I've got two isosceles triangles connected at a vertex. All right, so how are we going to figure this one out? So once again, the instructions are the same. I still have to solve for x. So if I'm going to solve for x, I've got to write an equation. So what we're trying to do is set up to find an equation that we can write out of this. Okay. Now, here is the first thing that we want to look at. Okay. Remember, if these two triangles are connected at this vertex, then remember these two angles are vertical angles, right? And what do we remember about vertical angles? Vertical angles are congruent. So if this one's 2x, I can label this one as 2x. All right, so that gets us closer to what we need. Now look at the triangle on the right-hand side. I have 2 of the 3 angles labeled in terms of x. If I can get an expression for that one missing angle, then I can add them all up to 180, and that would be my equation. That's what we're going to focus on. Here's the key. Look at these two congruent sides. Okay, remember what we said? The angles across from those sides are congruent. So if this one's across from a 4x plus 5, then the other angle should also be 4x plus 5. All right, so now take a look at what we've got. We've got all 3 angles on the inside of this triangle in terms of x. I can add all of those up to 180, and that's what we're going to do. 4x plus 5 plus 4x plus 5 plus 2x equals to 180. All right. I'll add all my x's together. 4x plus 4x plus 2x is 10x. 5 plus 5 makes 10 equals to 180. I can move the 10 to the other side, make it minus. 10x equals to 170. Let's divide that by 10. And my x is 17. And so that'll be your correct answer. So the whole key is using what we've learned about isosceles triangles to get to the point where we can create an equation. All right, let's look at the last one here. All right, so I've got, again, 2 triangles, but this time, instead of being connected at a point, they share a common side. They're connected by this side. Okay, I've got 2 marks here, right? And so that means this is an isosceles triangle. We don't know that the other one is an isosceles triangle because there's only one angle marked. And as a matter of fact, look at all the angles here. It's 90, it's 42, and here we've got a 48. All right, so we know, in fact, that this triangle on the right-hand side is not isosceles because none of the angles are the same. Remember, if the sides are the same, that would force the angles to be the same. So if all the angles are different, it's definitely not isosceles. All right, so how are we going to figure this thing out? Okay, let's take a look at what we've got right here. Remember, on the isosceles triangle on the left-hand side, these 2 sides are the same. That means these 2 angles are the same. So I can label this blank one, even though it has 1 mark, I can label it as 2x. Okay? Now, take a look at the other triangle. Isn't there another angle here that's labeled with 1 mark? Okay, there's another angle here that's labeled with 1 mark, and that's the 48 degrees. So what I can now say is, since these 2 are the same, I can write 2x equals to 48. And to solve that, all I have to do is divide by 2, and I got it. So now we have x is equal to 24. X is equal to 24. All right, so at this point, you're going to be ready to take what we've learned here and go and take your quiz, and it'll be waiting for you in Canvas.